Welcome to Chapter 9, Section 5, Equations, Part 2 video. Man, that's a lot of title right there. All right, so guys, do you recall way back when we first learned factoring, how I told you that factoring was going to haunt you over and over again the rest of the year? Well, welcome back to factoring. Notice the when in doubt. So I hope it would occur to you, look, there's an x squared minus 4x squared. We typically factor something like that. 3x plus 6. Is there a greatest common factor there? Yep. So it's really easy to match up the parentheses, like on this guy up here, when the parentheses are already there. But in this case, they are not. Let's try that again. The parentheses are already there, but there are no parentheses showing so far on this guy. So we got to create them. All right, here we go. When in doubt. I got a 2. I'm going to factor a difference of 2 squares for that guy into x minus 2x plus 2. So easier to match them up when that happens. The middle one, understood to be 4 over 1. Definitely need that one. And the last one, greatest common factor, your friend. We never forget that, right? X plus 2. So why was that helpful? Well, take a look. They both have x plus 2s. So we already know that that part matches. So does the middle guy have an x plus 2, though? Nope. So I got to put one there. Don't forget to do it to the top. The first one has an x minus 2. The second one does not have an x minus 2. I got to put that there as well. The third one has an x plus 2. He does not have an x minus 2. But he does now. So what do you think? Common denominators? The parentheses match. But oops, take a look at the third one. The third one has a 3. The other ones do not have a 3. Got to squeeze a 3 in. So that was messy, but we finally have common denominators. So let's double check. They all have 3's on the bottom? Yes. They all have x minus 2's on the bottom? Yes. They all have x plus 2's on the bottom? Yes. So it's a matter of us cleaning this bad boy up. First fraction, 3 times 2. Second fraction, quite a mess. So I'll tell you what. Let me go ahead and write this out, and then we'll get to it. So there was a minus, there was a 3, there was a 4, there was an x plus 2, there was an x minus 2. Clear down on the end, I'm doing 1 times x minus 2, which would be x minus 2. So where'd the denominators go? They were common. We get to cross those off. Good news. All right, well, at least I'm sure that would occur to you that that's going to be a 12. Little FOIL problem. X times x. The outside would be negative 2. The inside would be negative 2. They would cancel. So you wouldn't have to skip and not write that. Last one times last one, negative 4. I'll be a little lazy here, not rewrite the whole problem. So eventually, I have to distribute this guy out. So that was my middle fraction. Rewriting the first fraction, which was a 6. Rewriting the last fraction, which was a minus 2. So that's a quadratic equation. And a quadratic equation has to have everything on one side, 0 on the end. Let me clean these two guys up first. 54. X minus 2. So I'm going to move everything over to the right side. Wouldn't have to do it. You can move everything to the left side. Negative over there, I move him. He's positive. The x was already over here. So if I move the 54, I would have to subtract him to do it. That would be a negative 56. So like the last video, I would like to tell you that this factors, but it does not. So I would not give a quiz question like this to regular Algebra 2 students. You could expect this to factor. But everyone in my honors class has a quad program. We could run the quad program. And once you had entered A, B, and C, it would have told you the answers were 2.1 and negative 2.2. Let's go back to the original problem and check out the restrictions. So we could not have used 2 we could not have used -2. And even though those answers came close to that, they're still not restrictions. So these are our answers. 2.1 and -2.2. All right, in the box for the next problem, it says, oddly, it can get easier. I know you're not buying that, but 2 fractions instead of 3 this time. 2 fractions we're allowed to cross multiply. So yeah, it's going to make it a heck of a lot easier. So hey, let me write this down, and I haven't been doing it right away, and I should. I can't have 12 for an answer. If w equals 12, I get 0 on the bottom. So just to make sure that we know that. Cross multiply one way. Cross multiply the other way, which would be the distributive property. And look, that's pretty darn simple. So I'm going to move the 4w over. I'm going to divide by 3. And I get -16. And that guy's done. So that was not bad at all. But again, and you know it's going to burn you eventually. So we can't use positive 12 for an answer because it's in a restriction, but we did not get positive 12. So 16 or -16 is okay. Simple as that. So 2 fractions you can cross multiply. So here's another one. Now there is an easy way to do number 6, but I'm going to bypass that and just pretend like maybe you didn't notice it to prove a point. But it is 2 fractions, and if it is 2 fractions, I can cross multiply. Now that guy would be a FOIL problem. So outside 2, inside 2, last one times last. Cross multiply the other way is just distributive property. That'd be 2x minus 2. Man, I have trouble writing 2's with this pen. So quadratic equation. In a quadratic equation, everything has to be on one side. So I'm going to combine this guy and this guy for a 3x. And I eventually have to move everything over. So x squared, move the 2x over. I would subtract it, and I had 1. Move the 2 over, I'd have to add 2. And I'd have a -2 right there. And I got to equal 0 on the end. So that last problem did not factor. Good news, this guy does, but you could still run your quad program, assuming you had one. X and x, the only way to get 2 is 2 times 1. If I want to get that positive 1x in the middle right there, that's what my signs would have to be. What numbers make 0? -2 makes 0. Positive 1 makes 0. So why have I been yapping on about this restriction thing? Finally, we're gonna figure out why. So if I were to test -2 in that problem, and I plug -2 in, I'm going to tell you right now that it ends up being equal, and it checks just fine. But if I plug the 1 in, what would happen if you put 1 right there in the denominator? It would say 1 minus 1. 1 minus 1 is 0. Are we allowed to have 0 in the denominator? Nope. So that guy does not check out. He's called an extraneous solution, and I'm not allowed to have him for an answer. So that's probably why, guys, it would be a good reason. And so you're going to find this out for the next section anyway, 9.5 inequalities. You kind of have to do this anyway. So maybe it's a good idea to, at the very beginning, establish what the restrictions are, what x can't equal. And if x can't equal 1, then I cannot use that for one of these answers down there. So the answer to the problem ends up being -2 because -2 checks out just fine. All right, we're going to have to wrap it up here for part 2. Take a look at number 7. I assume you think that's a doozy, and it's because it is. All right, stay tuned for part 3.